Hi there, I'm John from CNCKing.com, and today I'm going to fiber laser etch some 316 stainless steel. When it comes to stainless steel etching, we've done a ton of it here in the shop. In this case here, it's a relatively small project, with just a couple of these that we cut out. So this is 316 stainless steel 10 gauge, and what you see on there is actually fiber laser etched. Now the reason why we fiber laser etch this, or the customers pay us to do that, is because they want something that's completely permanent. Meaning that you can stick it in a control panel, and even if that control panel catches on fire, won't affect this at all. Unlike, let's say, screen printing or UV printing, heat does affect the final result. The contrast that you see on this is actually created by the laser. So there's no inks, dyes, paints, any of that kind of stuff that could either damage something else or have sort of come off. So it can't peel, scratch. You just can't take it off. So that's why it's very much a very high value added item that we do a lot of. And most of the stuff I do is covered under NDAs, and I can't really do a video of it or take photos of it. But we have fiber laser etched panels that literally I had to feed into the machine behind me here because they're too big to fit just within that one area. Now you might be wondering, why did I use this machine instead of the Galvo machine? Galvo machine would be so much faster, and absolutely be a lot faster. The problem with the Galvo machine is you only have a very small area that you can actually etch. So for instance, if I was going to do this with the Galvo machine, I'd have to do this section, feed it through this section, feed it through this section, because the working area is very, very narrow. Now with the gantry system, it's a little bit different. The gantry system, you actually have the laser going back and forth. So however long that laser moves back and forth, that's your area that you could actually do fiber etching. The bad side about that is it's a lot slower, because with a Galvo you just have like a little mirror flicking around and it hits only the spots you want. While with this one here, it goes over a lot of areas that nothing really happens, but you're still sort of paying for the time-wise for the machine to go over those areas, because whether it's etching or not, it still has to go over, the space between the T and the R, for instance. While the Galvo is fast because it would just do the T and then it would just do the R. It doesn't care about this space. Now fiber etching is a very, very slow process, and there's no real way to speed it up properly that I've found through the years. What I mean by that is, let's just say these are not the real settings, but just give you an idea. Let's say I go 100% power and 50% speed. Well, you might think, well, you know what? If I go 100% power and 100% speed, I'll go twice as fast. And technically that's true. But the problem you'll have is the fiber is not on the surface area where you want long enough. And what that does is produce a very shallow etching. Now, I'm not going massively deep on this anyways, but the etching, I'd almost say that it doesn't have enough time to actually etch properly. And as a result, if there's any sort of warping in the metal and that kind of stuff, you have very little tolerance to play with when it goes to 100% power, 100% speed compared to 100% power, 50% speed. So what I generally do for tags like this, but far larger ones as well, is I really slow down the machine to do it properly. And it does add a lot of time to the process of etching the stainless steel in this case here. But the result is you have a consistent etching everywhere. There's no way to speed it up that I've found that actually produces a superior result. And you get to a point where some of these production times are kind of ridiculous. So then you're not going to go like 100% power and 10% speed, because that would take forever. Produce an amazing etching, but I don't have time to sit next to the machine for a week to do that. So whenever we do these kind of projects, there's a few different ways that come about happening. Sometimes the customers provide us with the actual material that we're going to etch here in the shop for them. Other times they just send us a spec sheet and say, this is what we want, cut it out for us. Then in that case, we either water jet cut it, plasma cut it, laser cut it. There's a tons of different ways of cutting stainless steel. Everyone has their plus and the minus. Now for something like this here, and I've done jobs where this was something, even longer, it gets very, very tricky. And the reason for that is because when you do the etching on the metal, it gets extremely hot. And something that's long and narrow that gets really, really hot really likes to warp on you really fast. So that's where the only way I found around that issue is, tons of air shooting down on it to cool it down, tons of air getting sucked out of the machine to, cool it down, get the heat out of the machine. And in addition to that, go with something as thick as you sort of affordably can. We could do stuff here. If this was an inch thick, we could do it. But you don't want to have the bill for the 1 inch thick stainless steel 316 of this stuff here. So it's always, a balance. You have the price point the customer wants to stick within, and you have the limitations of the technologies that are involved. So it's just balancing all of that, and it took quite a few years to get around to that. But now, most of the time when I look at a digital drawing, that's how most files are sent to us. I know right away, okay, well, we're going to use this to cut it, we're going to use this to etch it, this is how we're going to go about doing it, so that we get the most even result. Because what happens is, if this is not dead flat, remember the gantry is going over it. If this area here, let's say as an extreme example, we have it like this here. There, you can see it. So the gantry is always the same height. But if the metal is a different height, you have a different focal range. And what happens is, you go from etching to annealing to nothing. It's that simple. And the tolerances between those is incredibly tight with fiber laser etching. That's why it's very challenging to do very, very large panels, because we found that with large control panels, what happens is it actually starts to bubble up from the heat. And we've done, there's the huge vault we did a couple of years back that I have pictures of on my website. And that vault was quite a challenge, because although the plates were, I'd say, roughly this size, square, the challenge was they were full coverage. So that stuff loved to warp, and it took a while to figure out how to best go about doing that project without having a lot of issues. So if you're looking for custom fiber laser etching, contact me at CNCKing.com. We can do it for you and ship it right to your door.